Hello and welcome to our ninth lesson in the topic of carbon for Edexcel Geography A-Level. And today we're going to be looking at energy security. So first of all, we'll look at what energy security is, and then we'll go on to discuss why it matters that a country has a secure energy supply. And then we'll look at the UK in particular and its energy mix and decide whether it is secure. And later on, you'll be looking at whether you think that fracking might solve the problem for the UK's energy supply. And we'll look at how the UK compares with Norway in terms of its energy. We'll also be using some skills today and looking at some graphs to build on the skills you'll need for interpretation of figures. And the homework today is a 12-mark question: assess the energy security of the UK. All the resources for this lesson are in the lesson folder on the shared area for Carbon 9. So this is forms part of key inquiry question 2, and you can see that the learning objectives today are to recognise that countries do use a mix of energy to remain secure. So there's obviously more traditional energies like coal and oil and different types of energy that are more renewable. And there's some key terms there in the grey box which you also have to make sure that you can define. You can use your textbook to look these up, or you could do some research on the internet. So the first thing we're going to look at is what is an energy mix. So there's a definition there in the top grey box, and energy mix is defined as the combination of different available energy sources used to meet a country's top total energy demand. Exact proportions vary depending on the country, and it's an important part of energy security knowing where a country's supply comes from. So we have a mix of primary energy sources, and these are where you consume energy in its raw form, in other words, the burning of fossil fuels like coal, oil, and natural gas, and where nuclear energy is used, where certain radioactive elements make heat, basically, and there's some renewable sources. Secondary energy sources will be classed as the electricity that is used by homes and businesses, because these are obviously powered by primary energy sources. And another factor that we're going to look at is whether a country has a mix of domestic supplies, which means energy that you get from your home country, and imported sources. It's probably becoming aware to you now that the greater amount of domestic sources that you have, the more energy secure you are, as you're not relying on other people to import your energy. So can you think of any examples that might make your imported supply unreliable? There have been recent things in the news with Russian gas supplies, and the Russians supply a lot of gas to Europe generally. Civil war, invasions in Iraq, the current coronavirus crisis might affect energy supplies and the oil prices. So it's important to consider those factors. So the first thing we're going to look at is what is energy security. So this can be defined as an uninterrupted availability of energy sources at an affordable price. But it's important that you consider the long-term and short-term supply of energy to a country. So in the long term, a country needs to think about its future demands and supply and invest where appropriate. So, for example, considering how population might increase in the future might inform a country's decision as to what they might do going forward. Perhaps looking at political situations in some countries might lead a country to decide that it would plan to stop importing oil, say, from countries which may have political tensions in the Middle East. In the short term, energy supply and energy security is more to do with getting through winter, for example. So in the UK, ensuring that everyone in the UK has access to energy to heat their homes and to keep lighting and cooking going. So it's important to consider the long and short term. So you'll see on this graphic here that we have the world and its energy security, and it's measured on a number of factors, and the source of this is the Global Energy Institute. When you go back over the PowerPoint in your own time, you can click on the link there, and you can interact with each country and actually look at how the factors are put together. But you can see there that green countries are at the lowest risk in terms of their long and short-term energy supply. So if you were asked to describe where these places were in the world on a typical describe the distribution shown question, you would be able to say that the UK, some parts of Europe, including Germany and the Netherlands, and some parts of Scandinavia, Australia and New Zealand, North America, and some parts of South America had good energy security. Other countries on the scale going down have varying degrees of security. We can see there that the highest risk countries in red in parts of Northern Africa and the Middle East, and this is due to reliance on oil. Even if they're oil producing countries, the reliance on one product only is, despite plentiful supplies domestically, is a consideration for energy security. And also this is a reliance on fossil fuels, which are finite resources which will run out. You can see that there are countries that are greyed out on this map too. Greenland, parts of Central America, and a large number of countries in sub-Saharan Africa, with the exception of South Africa and one other country on the west coast there. And you'll see here that this is where these countries consume so little energy that they don't make it into the top 75, so they're not part of the graphic. So this will be to do with these people using primary energy sources and not secondary electricity sources. So there may only be electricity in the capital cities of these countries or in larger towns, and everywhere else people would be relying on primary sources of energy, for example, kerosene to fuel stoves and lamps, and in some places wood for fires. This slide is a large summary of energy security, and it's worth pausing the presentation at this time to take some notes on these points. So if we're looking at the sources of energy that are available in the world, you can see here that in 2010 we have total world energy consumption by source, and you can see here that we have a small chunk of the larger pie chart is for renewable energy. So what this tells you is that 7/8 almost of the world's energy is supplied by non-renewable sources. By that we mean fossil fuels in brown there. 80% basically is fossil fuels, and we have 16% of the world's supplies are renewables, and a very small amount of the world's supplies are nuclear. Nuclear is a funny one because it comes in the non-renewable category as it uses up resources from within the earth, such as plutonium. However, due to the fact that it is ongoing in its use and a small amount can lead to a chain reaction which leads to a lot of energy, it's not strictly speaking classed as a fossil fuel. And you'll see on the right-hand pie chart there that of the renewables, we have biomass heat as the largest source. So this is biomass means living things, and it just means wood and animals. But generally speaking, biomass is wood and plants that are burnt to make heat. We also have biomass electricity down there, where biomass is actually used to make electricity. And we have some other forms of renewable energies in there. We have solar hot water, where solar panels are used to make hot water. Geothermal, which is heat from the ground, from rocks under the surface, for example, in Iceland. Hydropower is to do with using lakes and rivers and dams to power turbines which make electricity. Ethanol is basically alcohol used to power vehicles. Generally speaking, this is quite a number one source of energy in Brazil. Biodiesel, diesel made from plant sources. Wind power, obviously windmills. Geothermal electricity, so electricity made by geothermal energy in rocks. And then you have two types of solar power there. Solar PV, which is photovoltaic cells, which is where you'll see them on people's roofs, where the sun is converted into electricity. And then we have solar CSP, which is the method that you may have seen in other countries, where you have large fields of mirrors which reflect the sun's light towards a source that can gather the energy. And then ocean power would refer to wave and tidal power. Also here on the next slide, we can see world energy consumption. So you can see here time along the bottom of the graph from 1820 to more or less the present day. And you can see that we have a range of fuels that are available for energy, from nuclear to biofuels. And you can see the changing amount of consumption of those fuels through time. The units for this are exajoules per year. And it's obviously a very large units because it's for world energy consumption. So the rate of change hasn't been consistent over time, but you can see here that around 1950, the amount of joules per year of energy that the world consumed jumped dramatically, and you would be wise to think about why that was and maybe link that to the Industrial Revolution. And you can see that from 1950 we've got three fuels that are dominating global use. So we have natural gas, oil and coal. So these are the fossil fuels. So it is another way of representing the same data really, and you can see on here that in the world, petroleum is one of the main sources of fossil fuel, and coal and natural gas, and then we have other forms of energy in the pie chart. And this is just another way of looking at the data so you can become familiar with pie charts and line graphs. So in case you are somewhat confused about what a fossil fuel is, these are fuels that come from old life forms. So we talked in class about how oil was decayed plants from the sea, coal, plants and animals. Coal is compressed trees from the Triassic period, and there's also natural gas, and coal is mostly made of carbon, so that's from trees. So it's just fossil just means that they're fossilized forms of trees or plants which have been subjected to intense heat and pressure over millions of years, and they were laid down when the climate of the earth was very different. So some students would say to me, but why can't we just wait for the trees to make more fossil fuels? But the climate of the earth is not the same as it was in the past where these things were laid down. And even if that were the case, the rate at which we use the world's energy supplies is far exceeds the planet's ability to lay down new fossil fuels. So who's got all the fossil fuels? So if we're thinking about energy security, we've got these sources from Wikipedia here, which show us on the top left here, we can see crude oil exports here. So Saudi Arabia exports more crude oil than anywhere else, but you can see the top 10 countries there, the oil exporting countries. This table down here shows coal exports, and you can see that Indonesia and Australia and Russia are big coal exporters. And natural gas here, you can see that Russia's the number one. So you'll see here that there are some countries that are rich in fossil fuels. So Russia is in the top three on all three types of fuel. So it's in a very powerful position in terms of its energy supply to other countries. But you can also see down here on this graphic here that we have countries who exports and imports of coal. So red circles indicate exporters of coal and green indicate importing of coal. So this may lead you to start thinking about how energy secure a country is. If a country like Australia is a big coal exporter but not an importer, it has enough in its domestic supply. But if a country like China is a big importer of coal, then perhaps this is not a very secure energy supply for China. So, but what's the problem with the reliance on fossil fuels, you might say? Apart from all the climate issues that fossil fuels are famous or infamous for, we can summarise some pros and cons of fossil fuels, generally speaking. So this graph on the left here shows the amount of carbon dioxide in the air from 1850 and projected by 2100, and the cuts required for the 50% chance of not exceeding 2 degrees. Now, 2 degrees is an important temperature or important temperature rise because this was the goal of the Paris Agreement, which was a world agreement to ensure global temperatures didn't rise more than 2 degrees above pre-industrial levels. So to stick to that 2 degrees, this graph shows what would have to be done in terms of how much carbon dioxide is emitted. You can see that the red line here shows the impacts of various events on carbon dioxide in the atmosphere. So the Great Depression here, slowdown in the reliance on fossil fuels, and then the post-war boom in industry and countries recovering, the oil crises of the 1970s, but in the last decade there has been no slowdown despite the grounds we've made in using alternative energies. So we can see some, on the right here, some disadvantages and advantages of fossil fuels. So perhaps it would be, people could argue, well, why are we still using fossil fuels when we've got these considerations about carbon dioxide in the atmosphere? And the answer to that would be it's something that's well developed and the technology is there and people are familiar, and it's been used to power our world for many decades. So many countries continue to use fossil fuels because it's familiar, and they're also cheap and reliable, generally speaking. So they're reliable forms of energy because once you've dug up coal, oil, etc., or natural gas, then they are reliable for generating power. That, unlike the wind, for example, and solar, which relies on things that can't be fixed. So the wind can blow and then the wind can not blow. The sun can shine and the sun can not shine. So they're seen as more reliable forms of energy. And when they were discovered, they were in plentiful supply. So it seemed obviously like a very good idea at the time. But we can see the disadvantages of fossil fuels, and some of these you'll be very aware of. The global warming issue, of course, with the release of carbon dioxide. They're not renewable. So this is otherwise known as finite. So once they're gone, they're gone. It's unsustainable. So we're using too many of them. They can't be replaced. They're cheap. So because they're incentivized by governments, so there's direct subsidies to keep these things going. And there are accidents that occur with the extraction and transport of fossil fuels. And this Guardian graphic up here on the right, this picture, shows the result of the Deepwater Horizon oil spill in the Gulf of Mexico, which was an absolute tragedy for wildlife and the environment generally. So these things happen. And again, this slide is a summary of fossil fuels and energy pathways, and you should pause the video here to ensure you have some good notes on this detailed area. If we look at the world's largest energy supply here, we can, whilst we wait for it to load, so you can see here that this is from the Visual Capitalist website, and it shows the world's largest energy sources. So it's worth looking at this a little bit more in your own time. But basically it's looking at, on the left here, we have forms of energy: solar, biomass, geothermal, wind, coal, oil, gas, nuclear, and hydro. And it's very interesting to see that certain forms of solar energy produce more energy than others. So within Europe, for example, the solar park Muro here produces enough power for 40,000 people in the European Union. And this current solar plant here in Shakti in India produces a lot of energy. It's the largest solar farm in the world. And this one here in China, the Tengger Desert, produces enough energy for 670,000 people. So it's worth looking at a bit more detail in your own time. You can see here, though, that the Drax power station in the UK up in Yorkshire is a biomass power station. So this provides enough energy for 3.4 million people in the UK, and it's powered entirely by wood. So if you've ever been up to Sheffield, you'll have seen the Drax power station. As you go up the M1, you can see the Drax power station off to the right as you're driving north. It's an enormous power station, and it is the UK's biggest supplier of renewable energy. So we've got geothermal energies here. So although Iceland is famous for its geothermal energy, We can see here that actually the geysers in the United States, so in geothermal parts of the United States, have actually produced more energy than the ones in Iceland, which are here. And then we've got wind farm. You can see that, again, the UK is doing well on renewable energy. So here is the Hornsey wind farm. Hornsey, as you may remember from your GCSE geography, is up on the Yorkshire coast, on the fastest eroding coastline in Europe. And when it's finished in 2025, it will be the largest offshore wind farm in the world, and it will produce a lot of energy for the United Kingdom. And then we have coal here, and we see that Taiwan has the largest coal plant in the world. And going down here, gas, we can see that the Russians have a large gas fields here, biggest in the world. Going down to nuclear, Canada, the Bruce power plant produces more energy than any other nuclear power plant in the world. And nuclear power is an interesting one because it's renewable and clean. Renewable in some ways, we'll come back to that. But it's a clean energy, but it's unpopular in some countries due to its perceived dangers and problems with disposal of radioactive waste. And then we've got hydropower down here, and the Hoover Dam, made famous, I think, by Harrison Ford when he leapt off it in a film. But down here, this dam here, what is that country? I don't even know. Paraguay, sorry, on the Brazilian-Paraguay border, is absolutely enormous, as you can see. But there's the Three Gorges Dam, the famous dam in China that you may have studied for GCSE Geography Rivers. It's an enormous dam. So, and you can see here that even this dam in Venezuela, the Guri Dam, is supplying 80% of Venezuela's energy. So there's lots of potential sources of energy. You can look at that in a bit more detail in your own time. So we also talk, when we're thinking about our country's energy security, about the world's energy transition. And if you take a look at this right-hand graph here, you'll see energy use per person and increasing level of economic development along the bottom there. And as time goes on, countries become more developed. And this graphic at the top here shows that this is a pre-industrial age, i.e. before factories in a country, the industrializing when countries are in takeoff mode, industrialized period when countries are manufacturing and have moved out of those primary industries, and post-industrial landscape where the UK is now and other more developed countries are. And you can see that not only does the amount of energy per person peak just before the post-industrial age, in other words, as countries get more developed, you can see that the amount of energy per person used drops. That's the first thing to take from this graphic. The second thing to take from it is that the energy mix, generally speaking, changes. So a country in the pre-industrial phase, some in sub-Saharan Africa, will mainly be burning biomass. And by that we mean trees, wood, animal dung, and some oil. And that will be oil in the form of kerosene for lamps. And as countries move through various stages of development, they will discover coal. Coal will peak in its use in the industrial era, along with gas, and then the amount of coal will start to drop and be replaced by renewable and nuclear energy. So it's important to see how countries change as they go through their industrial to post-industrial growth, and the energy use per person increases to a certain point and then decreases because energy use becomes more efficient the more technological we get. So there's a typical exam question here on the bottom, and it's from the old Edexcel spec, but nevertheless it is relevant because it's the same topic. It's just the actual marks are allocated to this question might be different from your paper. So it's just asking, using figure 1, which is this, explain why as countries develop economically they move through the energy transition. So you might want to think about how if a country gets richer as it moves through its economic development, why that enables it to access different forms of energy. So that's something to think about if you want to try this exam question. And then the next part of this question is asking to what extent are domestic energy resources important in determining the energy security of countries. And this is a very similar question to the homework question about the UK's energy security, and also the exemplar question which you will find in the folder, which I will come on to later. So you could have a go at this question, and you could send that to me if you would like to, or you could just think about it and maybe make some notes on what you might do. So if we go to look at the UK now in a bit more detail, we might see here a graphic from Good Energy, who are an energy supplier that supply renewable energy to the UK. And we can also see this pie chart here that shows how the UK was doing with its energy supply in 2016. And perhaps quite surprisingly, coal is only 9% of our supply, and that will have dropped again. Gas supplying 44% of our supply, and various other sources. We've got biomass and wind and nuclear here. And this shows on the right, though, however, how secure we may or may not be, because 61% of our energy actually comes from overseas, or of the fuel. So you can see here a breakdown of where our energy comes from. So this is saying that of the 61% that we import from overseas, 54% comes on boats. And you can see that where our energy comes from, so 12.5%, Russia's our biggest supplier there, coming into the UK on a boat. And this graphic at the bottom here is a pipeline, and it's showing that 8.7% of the UK's energy is piped under the ocean from these various countries, so Norway, Denmark, Germany, the Netherlands, Russia and Qatar. So if you think about the amount of energy that the UK imports, are we energy secure? So hopefully this next slide will show whether it will give you the answers to that question. So you can see here that between 2000 and 2012, the UK's energy supply has changed dramatically. So in 2000, the UK exported more than it imported, but by 2012, the UK imported more than it exported. So it has moved from a position of relative security to a position of relative insecurity. And we know from the previous slide where we get our energy from. So you can see some of the countries where we get our energy supplies from, and we can see the current political station in some of these situations in some of these countries, so we can see whether they are stable or not, because the political stability of a country dictates to a large extent how secure our imports are. So apart from the cost of 24 million, what we spent on energy in 2012, you can see here that some of our energy comes from Libya, and which was undergoing a civil war after the fall of Colonel Gaddafi. So it's a newly industrialising country. So if it's undergoing civil war, this makes it an unreliable source of energy. Angola is a country in sub-Saharan Africa, and it's currently peaceful, but it has had lots of civil war, and it's a low income country. So it's possibly not a reliable source of energy. Nigeria has a large amount of oil, so it's in one sense it's energy secure, but as an importer, it has a lot of fighting from Boko Haram and Islamic terrorist groups, so it's probably currently quite energy insecure. And we import quite a lot of stuff from Europe, so France, Norway and the Netherlands. These are peaceful countries that we have had long alliances with, so perhaps these are secure sources of energy. Qatar is another source of our energies in the Middle East. It's obviously an oil exporter. However, we've talked about this in class. Qatar sends its oil to us on tankers, and the tankers from Qatar exit the Red Sea via Somalia, basically, in the Gulf of Aden. So there is a problem with piracy in this part of the world anyway, so Somalian pirates are increasingly desperate and increasingly sophisticated in their attacks on tankers and ships, and therefore this is possibly not a very reliable source of energy. So you can see that Russia supplies a large amount of the UK's gas, and in 2012 was in a dispute with the Ukraine and the rest of Europe and the UK, and therefore at one stage turned off its gas supply to Europe, which caused some outages of energy in large parts of Europe. Russia is currently stable. However, this subject is subject to change at all times. So hopefully this has given you some idea about whether you feel that the UK is energy secure or not. Now we're going to look at the UK compared with Norway. Norway's generally speaking believed to be a very secure country in terms of its energy. You can see here down here that this is where Norway is. Obviously have to be able to identify that, and this is obviously the United Kingdom. So you're going to make a quick table in your notes with factors down the left hand side like this, and the UK and Norway in 2 columns like this. I have just put this white box here to blank out the answers. You don't need to make a very fancy table. It's just going to be easier to take notes, but make sure you leave a lot of space to make this table in your notes, because there's quite a lot of statements you're going to be putting in it. So you should pause the video at this point and make your table, and then when you're ready, we'll move on. So you should have drawn the table on the previous slide and be ready to fill it with some statements. So this slide shows a number of statements that need to go into your table, and you need to decide, if we flip back to your table, whether these factors belong to the UK or Norway, and whether they are to do with physical availability, cost, technology, political considerations, level of economic development, or environmental priorities. So these statements go in some sections of that table, and you should pause the video again and either number the statements in your head and put them in the right place on the table, or make notes and copy them into the table. So you can pause the video at this point to do this task. And hopefully your finished table looks like this, so you could check to see if your table has your factors in the right place. If not, at least you have a copy here on the slide of the correct version. This is also in the Digby textbook. So we've talked about energy security, and we've talked about the energy mix of a country, and we've talked about energy sources generally and how the world's energy changes over time with development. So in order to test what you've learned, you should attempt to answer the following 2 questions. So these will be typical questions that you might see at the start of a longer question. So question 1 might be, what is energy security? And that might be worth 4 marks. And the second question would be, what is meant by a country's energy mix? And that would be worth 6 marks. So you can pause the video again at this point, attempt to answer these questions. Maybe the way to do this is to actually set a timer for 4 minutes and try and answer the question in the time you would answer it in the real exam. And then again, try the second question and pause the timer for 6 minutes and try and answer it. If you can't answer it, you should go back over your answers. You should go back over the PowerPoint and have a look at the definitions for these so that you can answer them without having to look at your notes. So here are the answers to the questions, and hopefully your answers were very similar to these answers, because these are the ones taken from the slides. So if you didn't get the answers that are similar enough to these, you need to revisit the PowerPoint and have a look there at these 2 definitions. It's very important that you know what they mean as we move forward in the course. So I've come to the end of the formal part of the lesson talking about energy security. Thanks for bearing with me at my first time. So I'll get more slick at this and there'll be less weird pauses. So bear with me. These are the tasks you ought to complete after viewing this video. All the resources are available on the portal in the normal location, Carbon Lesson 9, Energy Security. So there is a sheet called the UK Energy Mix Skills version 2. You should have a look at this and complete the tasks. There's some reading to do. Read the resource, What is Energy Security? Read the Digby pages that are in the folder. You don't need to have the textbook. Complete any tasks on the Carbon Lessons 9 info and task sheets, which follow this PowerPoint more or less. There's an Economist article on European energy security. And then before you attempt the homework essay, you should have a look at the exemplar essay. The exemplar essay title is Assess the extent to which one or more countries is energy secure. And if you look at that one, which is 12 out of 12, it will really help you to answer your homework essay, which is Assess the energy security of the UK. So the way you would answer that last question for homework is you would look at the layout for the one for the exemplar and then use the information that you've gleaned from this presentation and from the resources to see what the energy security of the UK is like, judging from its imports. So good luck with that, and have a look at slide 23 where you should do some prep for the next carbon lesson, and I will see you soon.